It is great to be joined today by Martin Levy, who is the co-founder at Tatau, which is a very, very interesting ICO blockchain-based project working in the space of artificial intelligence, AI computing, deep learning, all very interesting areas to me. So first and foremost, Martin, thanks very much for joining us.
Thank you, David. It's great to be on your show.
So let's start first with, if one has a general understanding of what artificial intelligence means, they may not have any sense of the problems that are very quickly developing within that space as we start to learn about the amount of computing bandwidth that is necessary for a lot of what is going to be taking place within this world. So talk to us first about the problems that AI is very quickly going to come up against.
Sure. So AI companies today, their compute requirements are growing significantly. In fact, AI companies' compute requirements are doubling every 3.5 months. That's 5 times faster than Moore's law. So staggering growth. And with staggering growth in compute requirements and compute comes staggering growth in compute costs. So what you have is innovative AI companies being constrained in their innovation due to the price of compute. And so what we're looking to do is to unleash or unlock and accelerate innovation right across the AI and machine learning space by reducing the cost of compute.
Is there any way to quantify that a bit for our audience? In other words, like, I don't even know what metrics might exist to say, if you imagine this great thing that could be done with AI or a deep learning project, here is how much computing power would be required for that, and here's what it would cost. Like, are there any good examples of that to help the audience visualize the scale we're talking about here?
Sure, we're working with our early customers in AI space, and for smart cities, we're machine learning in terms of artificial intelligence for customer service, and these companies are facing compute costs of around $10,000 a month, going up to $20,000 a month, and rising every quarter. So significant amounts, and they're using teraflops of compute, and they're using it from the big four, buying it from the big four suppliers of compute globally. And those companies are essentially using price as a lever to constrain usage. Because of the price, these companies are inhibited from doing as much compute as they want. And AI companies tend to do compute in 2 areas. Firstly, to train their models. So they put up a big data set and a model, and they run the model over that data to come up with an answer. And that's an initial compute, and that's where we're focusing, versus the live compute or the real-time interaction. So if you think Alexa, training Amazon Alexa, that's where we sit, versus interacting live with Amazon Alexa. Both of those 2 things use a significant amount of compute, and the amount of that compute is doubling every 3.5 months.
So before we get into the Tatau platform and how you're going to work with this issue that's taking place, what is on the horizon when it comes to AI and deep learning that maybe people who aren't as involved as you are might not know about? I mean, what are some of the just exciting and innovative things that, pending the availability of computing power and the price of that power, are on the horizon?
So some of our customers are in the customer service space, the smart cities space, the drug discovery space. So just imagine if you could dramatically shorten the time for drug discoveries using machine learning and artificial intelligence. That would be significant. Imagine being able to contact your supplier, maybe your communications supplier if you've got an issue, and speaking to a human-looking customer service agent that has genuine AI that can access your account, understands you, can read your facial expressions and respond in real time to your mood. That's the type of innovation that we're seeing.
Yeah, there's some very interesting stuff going on in the telemedicine and AI medicine space where it's amazing what is happening with, given a set of sort of symptoms and clinical history, how very quickly AI will become better than both new and experienced doctors at diagnosing. It's amazing what's on the horizon, it feels like.
Absolutely. And so you can imagine talking to a virtual doctor or a virtual health agent, and they're listening to your symptoms, they're listening to what you're saying, they're looking at you, the camera is analyzing your face, maybe you're showing them an injury or a symptom, and that is getting scanned against a database in the background, and then AI and machine learning is used to come up with a diagnosis or a possible scenario. And the more compute that is available, the faster that result is able to be delivered. And the more compute that available, the larger the collection of resources are able to be looked at to give a better chance of the correct diagnosis.
So clearly a lot is happening, a lot is on the horizon, but there is this problem of the cost to compute. Talk now about the idea of Tatau and the project you're working on, and what solution to that problem could be provided here.
Great. So we are enterprise focused, and we're a distributed computing platform, and our vision is to become the largest supplier of compute without owning any computers. And so we're able to deliver cost-effective compute to these AI companies, or in fact also to companies in the film and television industry that are doing rendering. So you can imagine rendering requirements moving from 4K to 8K to 16K are growing significantly as well. So we're able to provide more cost-effective compute by harnessing and reusing and accessing existing globally distributed GPU-based assets that are already out there. Think crypto mining, think high-performance computing centers. These crypto miners have deployed hundreds of millions of dollars worth of GPUs to mine crypto assets. And the returns that they're getting from these assets are less than they forecast and less than expected, especially now with the current price of crypto coins and tokens. And so we're able to present them with a higher yield, a new revenue stream, a diversified revenue stream, and pay them a lot more than they earn from mining cryptocurrencies. And we package all of that up on a global basis, and we present it in a platform, and we sell compute to these AI companies for a fraction of the cost that they pay to the big compute suppliers today.
Is there an analogy here? Is there an analogy here to sort of Amazon Web Services, except in AI? The idea of having the resources, when it's Amazon Web Services, you're talking about either storage or bandwidth for websites and e-commerce, et cetera, that is scalable and on demand on a sort of as-needed basis. Is that the idea within the AI and deep learning space?
So you can look at us from an analogy perspective as the Uber of compute. And so we are able to access a massive supply of globally distributed GPU-based resources, and we package that up and we provide it to these AI companies. And remember, at the moment, in our first release, we are concentrating on the upfront compute that's not necessarily the real-time compute. So at the moment, if you were an AI company, you would come to us for your upfront compute requirements and save significant amounts of money with your innovation and get your products, your applications to market faster by going with us. We democratize access to computing by lowering the prices and making it globally available. And then for your real-time compute today, you would still use your existing supplier. But over time, we will be able to provide geographically diverse, localized high-performance computing live as well.
So when we talk about mining and GPU power, it would be downright inappropriate of me not to bring up an issue that is increasingly being discussed along those lines, which is that of energy consumption. And not only is what you cited a problem when it comes to GPU and mining, when it comes to the subpar or less than expected returns that some of the miners are getting, particularly with the lower pricing that's going on, there are also serious concerns about energy consumption. Can you talk a little bit about the interplay or overlap between that issue and the crypto mining that's going on, and the possible transition over to providing these resources for AI and deep learning?
So, energy usage is fine, provided that it's productive and it's used in a sustainable way. What we're seeing is the energy used for crypto mining is significant, and that's putting a strain on localized areas where the significant mining operations are underway. And many in the community see that as an unproductive use of power. So what we're saying is let's redeploy those assets to productive innovation, to accelerating innovation in artificial intelligence, to unleashing new waves of applications, that is a lot more productive than mining for cryptocurrencies. Furthermore, it's in fact more economic and a better yield and a return for the crypto miners to redeploy those assets towards productive computing. And for us, leveraging existing deployed computing assets is much more sustainable. That's better for us, it's better for the planet to reuse existing resources rather than deploy new infrastructure.
Yeah, there's like a debate that exists that feels analogous to this in the United States and the political world around the deficit and deficit spending. And if you're starting from the point of view that a dollar of deficit is always just a dollar of deficit, you're kind of missing the point, right? Which is, what did we go into deficit in order to achieve? What are we doing with that dollar deficit? You could do very productive things with it, or you could do very economically unproductive things with it. It seems analogous to what's going on with this computing power. The computing power is available, the GPU, the video cards are there, and it's really a decision about what is most useful to do with that power, is it not?
So absolutely. So investors look to deploy capital to make a return, and a certain class of investors have chosen to deploy capital to make a return in crypto mining, and that is seen by some as an unproductive use of power or of an asset. If that asset is redeployed into unleashing innovation for artificial intelligence, machine learning, and for the film and television industry, the impact or the output of the use of those assets can impact millions of people, right? It's a significant difference from mining for cryptocurrencies versus using your GPU-based assets globally for improving innovation in AI.
Let's talk a little bit about the Tatau token. What will be the purpose of the token? What does it do in the ecosystem?
Right, so the Tatau token is the exclusive economic unit on the Tatau platform, and our customers use that to buy compute power, and we in turn use that to pay our compute suppliers and our validators, those companies or those assets that verify and validate that computes have actually been done. And we use that, of course, with a smart contract to enable the transaction and to split the payments. Just remember, when a compute request comes in from our customers, they load up that request on our platform, and then we use blockchain to break that compute request up into thousands of pieces, and we send that out to distributed GPUs to be computed. That then is verified with verifiers who need to be paid, and then it is brought back, it is reaggregated and sent back to our customers at the end.
So if I'm an end user, because it's distributed, I might be lending my GPU power partially or fractionally towards a telemedicine AI, for example, and then on the other hand to a project that might be on the other side of the world and related to education or financial services. It's this sort of fractional lending of that power for which I as an end user can be compensated.
You've got it exactly right. So you won't know where, if you're in Sweden, if you're in Singapore, and you make available your GPUs, you don't know where they're being used or where the end customer is. That's all secured and sandboxed and separate from the supplier. And our customers could be anywhere in the world, and then the output of your compute is joined together with the rest of the compute to deliver the result back to our customers.
Who sets the rate of compensation for the end user for different types of projects that computing power would be used for?
So our economic model sets the price that we pay our suppliers, and our economic model sets the price that we charge our customers. And the price that we charge our customers is significantly less than the price that they pay for compute to the big four compute suppliers today. And the price that we pay to our suppliers is significantly more than they earn mining for cryptocurrencies today. So in that area is the elasticity of our price and our margin.
How do you make money?
So we make money, Tatau itself makes money through charging a margin on compute as the transaction goes through the system, through the platform. So what we sell compute for is more than what we pay our suppliers in aggregate for compute, and that's how we make a margin. And still, that is significantly cheaper for our customers, allowing them to do more compute for their dollar.
Can we touch a little bit on the ICO stages and sort of the timeline you're looking at?
Certainly. So Tatau was founded late last year, and in April of this year, we closed our seed round, 1.5 million. That was oversubscribed significantly. The participants in that round were crypto funds and family offices and high net worth investors, and all of the founders also invested in that round at the same rate. We released our MVP, a minimum viable product, in August, and this month we commenced our private pre-sale of 20 to 40 million US dollars. And we'll deploy that capital towards innovation, accelerating the development of our product, and towards our go-to-market strategy, our marketing.
What do you see as the biggest sort of systemic challenge to what you're trying to do? Is it adoption? Is it the crypto and ICO space more broadly, or something else altogether?
Well, I think what our investors are saying back to us to date is the most exciting part of our platform or our project is our go-to-market strategy. So we are an enterprise-focused supplier of compute. So our go-to-market has nothing to do with blockchain and nothing to do with crypto. And we're essentially a B2B play. It's an old school execution model, and our team are seasoned experts at execution. So we will package our platform and go to market selling compute in the same way that compute is sold to existing AI companies today. It's just that we're cheaper and we provide more efficient compute outcomes. So that's the go-to-market strategy is not dependent on our customers understanding the nuances of blockchain or crypto at all. And in fact, when they come to our dashboard and they buy their compute, it's all priced in US dollars to enable easy benchmarking with the other compute suppliers. And then in the background, a token conversion happens. And then when our suppliers receive our tokens, they can convert those on exchanges into cash, into fiat, or into other currencies. That's on the one hand. You asked also barriers to entry from a capital raising perspective or a token sale perspective. We're seeing many of the crypto funds now who were holding ETH are finding that the aggregate amount of their fund has reduced substantially. So we're seeing a lot of new entrants into the crypto or blockchain investment space. These are coming from family offices, high net worths, or more traditional funds focusing on a more venture capital based approach, who are looking at the team, they're looking at the market problem, they're looking at the solution that we've come up with, our technology, and our ability to execute, and our ability to go to market and survive as a business.
Yeah, we're seeing a lot of the same. That's for sure. We've been speaking with Martin Levy, who's the co-founder of Tatau. You can find out more about it at tatau.io. Martin, a real pleasure. Thanks for sharing all of this with us, and I appreciate your time today.
Thank you, David. It's a pleasure to speak with you.